Hello, and today I will talk about basic differential equation using integration. So, basic differential equation. So it's a first order, and there's a function of x. So function of x. So dy by dx equals to function of x. And to solve this, we need to solve y equals to. And by doing to do that, we can actually manipulate this to making it like this. So dy equals to f of x dx, and integrating it, so integrating both sides, we'll have integrate integral of dy is just y, and is equals to integral of function of x is big F of x is plus a constant. So this is just a function that is shift down vertically. So let's say we have y is equals to um, x squared plus some constants. So it's a family of curves. For example, here and here and here. So it just shifts vertically. This is the plus c. So it just shifts downwards or upwards. That's basically it. And let's get to the practice questions. So we have dy by dx equals to x cubed plus 3x minus 1. Like before, we can put it like this. dy equals to x cubed plus 3x minus 2 dx. And we integrate both sides. We'll have y is equals to, well, integral of this is just 1 over 4 x to the 4th, and plus by 3 over 2 x squared minus by 2x plus by a constant of integration. Well, that's basically it for number 1. Next, number 2, dy by dx equals to x squared square root of x cubed minus 1. Well, we can use substitution in this, but let's make it like this first. dy equals to x cubed square root of x squared square root of x cubed minus 1 times dx, and we integrate both sides. We'll have y equals to, well, this we use u equals to x cubed minus 1 du is equals to 3x squared minus 1 minus 0, because the derivative of a constant is 0, and this du and dx, and dx must be du over 3x squared. Okay, and we have our x squared integral x squared square root of our u square root of our u, and du is just, dx is our du over 3x squared, and notice we can cancel this, and we have just the integral here, y equals to the integral of square root of u over 3 du. Since 3 is just a constant, we can take it out, so y equals to 1 over 3 times the integral square root of du, du, and then, well, this is just u square root of u is just u to the half, and then you integrate this, we have 1 over 3 times 2 over 3 u to the 3 over 2, because a half plus 1, and then plus by a constant of integration, and here we have 3 and 2 over 3, the 3's can cancel. We have 2, 1 over 2, u to the 3 half plus constant, and u here is x squared, x cubed minus 1. And we'll have a half x cubed minus 1, 3 halves plus a constant of integration. That's our y. Okay. Next we have, okay, so we do like the previous, x cubed e to the negative x plus x dx, and we integrate both sides. Okay, y equals to integral of x cubed e to the negative x dx, plus we can split this into two parts, x dx, and we have to use integration by parts for this. So we have integral x cubed e to the negative x dx, u equals to x cubed, and the v equals to e to the negative x dx, and we integrate this. We have v equals to negative e to the negative x d, yep, just v equals to negative e to the negative x, and we'll have u du is equals to 3x squared, right? And then we have, you know that the formula of integration by parts is uv minus integral v du, and u times v is just x cubed times our negative e to the negative x minus integral of v times by du here. So negative e to the negative x times by our du. Du is this one, dx. 3x squared dx. 3x squared dx, right? And we have to integrate this also. So minus x cubed times e to the negative x, plus we take out the negative, and we have integral of e to the negative x 3x squared dx. Using integration by parts again, we have u2 equals to our 3x squared, and we can actually take 3 outside, so we have negative x cubed times e to the negative x plus 3 times integral e to the negative x squared dx. Okay, we have u2 equals to x squared, du2 equals to 2x, and our dv2 is equals to e to the negative x, and v2 equals to negative e to the negative x. Okay, and again, negative x cubed times e to the negative x plus by 3 times our integral u2 times uv2, we have x squared minus times negative e to the negative x, and then minus the integral v2, which is negative e to the negative x times du. Du is 2x dx, right? Alright, so we have another integration by parts. So negative x cubed times e to the negative x plus by 3 times we have negative right here. So we have negative x cubed e to the negative x minus x squared, 3x squared, right? 3 times x squared e to the negative x, and then we have e to the negative x, and then minus by 3 times the integral. We can actually make it positive because negative and negative becomes positive. 3 times the integral, that one, 3 times e to the negative x 2x dx, right? Okay. And let's see. So we have minus, yeah, this is correct, plus 3 times the integral. Okay, we have another substitution. So we have u3 equals to 2x, and du3 equals to 2, dv3 equals to e to the negative x, and the same v. v3 equals to negative e to the negative x. Okay, and our resulting in the integral will be u3 times, so we have 2 negative 2x e to the negative x plus by the integral, I mean minus by the integral, wait, minus and then v3 du. So we have positive integral 2 e to the negative x dx, right? And this is negative x cubed e to the negative x minus 3x squared e to the negative x plus by 3 times this one, and negative x cubed e to the negative x minus 3x squared e to the negative x minus 6x e to the negative x plus by, well, 2 times the integral of e to the negative x is just minus negative 2 e to the negative x plus a constant. Okay? And okay. So yeah, this is correct. And now we have oh yeah, and we put this inside here. We have, oh, there's a lot, so we have to simplify it, and it will become, wait, this 3x, and then oh, we can't, so we just solve integral of x squared, I mean x dx. We have, should be plus by x squared over 2, and can it be simplified here? Yes, by this, and we combine them, so we have x squared over 2 minus 3x squared e to the negative x, right? And our resulting is over 2 minus 6x squared e to the negative x. Alright. Okay. And well, I believe we just put it, yeah, here. So we have, well, how about we, yeah, just split them. So we have minus x cubed e to the negative x minus 3x squared e to the negative x minus 6x e to the negative x minus 2 e to the negative x plus by x squared over 2 plus a constant. So yeah, so these two will produce a constant, but we can combine the constant into a general constant. So yeah, we just have one constant. Okay, so this is our y. Sine of 2x minus 1, and minus by the integrand, the integral v. So our v is this one is a half sine of 2x. So a half sine of 2x, and then times by our du. Our du is dx. So we just have this one. Sorry, this is minus 1. Sine of 2x minus 1. Sine of 2x minus 1. And integral of sine of 2x minus 1 is just negative cosine. So we have plus integral, plus by cosine. So we have plus by a half. A half times a half is 1 over 4. 1 over 4 cosine of 2x minus 1. And we have, okay, so let me write, this is the previous question's answer. And let me write this as x plus by x negative, x minus, right? X minus x squared over 2 cosine of 2x minus 1 plus by x over 2 sine of 2x minus 1, and then we minus by a quarter cosine of 2x minus 1. So this is our solution. Let me just write it as y. So this is equals to our y. Okay, next we have dy by dx equals to 3 over square root of 1 minus x squared plus 1 over 1 plus x squared. So like before, we have integral 3 over square root 1 minus x squared dx plus integral 1 over 1 plus x squared dx. And we can see that we can use trig sub x equals to sine theta for the first one, and we have dx equals to cosine theta, right? And we can use the triangle here, and we know that sine theta equals to the opposite over hypotenuse. So the opposite is x and the hypotenuse is 1. So using Pythagorean theorem, adjacent should be square root of 1 minus x squared. And we have integral 3 over square root of 1 minus sine squared theta cosine theta d theta And as we can see, 1 minus sine squared is just cosine squared. We square root that, we have cosine theta d theta. Cancel these, you have 3 times the integral of d theta, which is just 3 times theta. What is our theta? Well, we don't need this, so um, theta is equal to sine inverse of x. So we have 3 times sine inverse of x plus some constant k plus k. And we have the second integral. We can use x equals to tangent theta for this. And dx equals to secant squared theta d theta. And as you can see, if we integrate 1 over 1 plus tangent theta squared secant squared theta d theta, well, 1 plus tangent squared theta is just secant squared theta. So secant squared theta secant squared theta d theta. Cancel these. We have integral of 1 d theta. We have theta, and theta is just tangent inverse of x. So tangent inverse of x plus some constant, let's say gamma. And we conclude that this is just y equals to 3 times sine inverse of x plus k plus tangent inverse of x plus gamma. Well, since gamma k and gamma is a constant, we can combine them. 3 sine inverse of x plus tangent inverse of x plus constant of integration. Well, that's basically it.